Hello everyone, welcome. We are studying sets, chapter 1 of class 11th. In the previous session, we have discussed about various types of a set in which we have studied empty set, singleton set, finite and infinite set, equal set and subsets. Today we will going to continue with subsets. So let us recall what is the definition of a subset. A set A is said to be a subset of B if every element of A is also an element of B. Remembered? So let us observe some important points by this example. In this question, we have to identify which of the following A, B, K and N is a subset of the set H. Let us start with the first part, which is A. It is representing a set A which is having two elements A and B. Yes, you may notice that each element A and B is also a member of the set H. So, A is a subset of H. Now, the set B. B is an empty set. Can it be a subset of H? Yes, it is, since it has no elements. So, we cannot deny that this element is not present in H. So, empty set is also a subset of H. Third set K, it is visible that this element E is not a member of the set H. So, K is not a subset of H. Lastly, the set N, all the elements of set N, A, B, C and 1 is also a member of set H, A, B, C and 1. So, yes, the set N is a subset of H. Let us observe some points in it. You may observe that empty set is a subset of every set. Yes, the same reason that empty set has no elements. Also, every set is a subset of itself. Why is this so? As each and every element will be the member of the same set. So, yes, every set is a subset of itself. Third point states, if A is a subset of B, that means every element of A is in B, and B is a subset of A, that is every element of B is in A, then this implies that A is equal to B. Example is there in front of you. You can see this part D. N is a subset of H, also H is a subset of N, and yes, we can see N and H are equal sets. Now, the last point, students notice when we have two sets and A is a subset of B, but A is not equal to B. That means there always exists at least one element in B which is not in A. Then the set A is said to be a proper subset of B and B is said to be the superset of A. Now, notice which among these, which are the subsets of H, are proper subsets or not. You may see that the set A and B are proper subsets of H, but N is not the proper subset of H. Why this so? Because N is equal to H. Such set is said to be improper subset, okay, or we can say improper sets. A is a proper subset of H and H becomes the superset of A. Okay, students, let us take one question on it. You can see this question. What this question states? We have three sets A, B and C, where A is a member of B. Notice the word member. Also, B is a subset of C. So, we have to state whether A is a subset of C or not. Yes, you may see that it is not true. So, let us take an example and see why it is not true. Here we have taken 3 sets A, B and C. A is a singleton set consisting of a single element 2. B is consisting of say 2 elements, and remember the set A is a member of B. That means the full set A will become the member of set B. So, B is consisting of set A and any other element, say 3. Now, see the construction of the set C. C is consisting of 3 elements, 1, set 2 and 3. And yes, it is satisfying this condition, that is B is a subset of C. As you can see, every element of B is there in C. So, set 2, 3 is a member of C. With any other element, let us take 1. Now, see this, that A is not a subset of C. That is, A is not a subset. For this, we can see what is an element of A? 2. 2 belongs to A, but 2 does not belongs to C. So, this states that A is not a subset of C. Students, you may observe a note or important point in this is that an element of a set can never be a subset of itself. Okay? Now, so let us study about subsets of real numbers. We have studied various set of numbers, which are set of real numbers, set of rationals, set of integers and set of natural numbers. You also know that naturals, every natural number is also an integer. Every integer is also a rational number, and every rational number is also a real number. So, it is obvious to see this relation. What is this relation states? That the set of natural numbers is a subset of integers. The set of integers is a subset of the set of rationals. The set of rationals is a subset of the set of real numbers and other relations as well. So, let me ask you one question. In this, we can see, is the set of naturals and the set of integers is a subset of this given set K. And what is this set K? K is the set of all those real numbers which are not rationals. So, let us suppose N is a subset, then every member of N is also a member of K. So, that means if 3 I have take a member of N, then 3 also belongs to K, which implies 3 is a real number, but 3 is not a rational number. But we know that 3 can be written in a P by Q form. So, this implies it belongs to rational. Okay? So, this states that 3 does not belongs to K. Okay? And it states that the set of naturals as well as the set of integers is not a subset of the set K. Students, observe, what is this set K representing? Yes, you may see that it is representing the set of all irrational numbers. Okay? Now we were going to study about intervals as a subset of real numbers. Now, you can see that this is a Cartesian plane, and if suppose I have asked you what will be the collection of all those numbers which are lying between 2 and 5, where 2 and 5 are not included, or the collection of all those real numbers which are lying between -5 and 4, where -5 is included but -4 is not included, then these set we can see are representing subsets of the real line, and such type of sets are known as intervals. So, let us see the definition of interval. The definition states, let A and B belongs to R, any two arbitrary number, where A is less than B. So, we are taking any two real numbers where A is less than B, then the set of all those real numbers which are lying between these two numbers A and B, then this set is said to be an open interval. Why open? Because the elements, or we can say the interval, is not including the endpoints. It is denoted as this: A, B with the curved brackets. All the points between A and B belongs to the open interval, but the endpoints A and B are excluded. Now, the next type comes out to be the closed interval. When we include the endpoints, then the set becomes closed interval. Students, observe the notation. Here, the brackets are changed into square brackets. So, the square bracket is representing that the endpoint A and B in the interval are included. Okay? So, again question arises, can there be an interval in which one point is included and other is not included? Yes. So, here is the next. We can also have intervals closed at one end and open at the other. As we can see this is an interval of collection of all those points which are greater than A and equal to A but less than B. So, it is representing that x can also take the value A, but x will take all the values which are less than B. So, it is the collection of all those real numbers. This interval is said to be semi-open and semi-closed intervals, where it is closed on the left but open on the right. As you can see, it is an open interval from A to B, including A but excluding B. Similarly, we can have a semi-open and semi-closed interval where it is open from the left but closed from the right. It is the collection of all those real numbers which are greater than A but less than and equal to B. Here, A is not included but B is included. So, whenever a point is included, symbol in the interval, the bracket will be used square bracket, and whenever the element is not included, so we will going to use a curve bracket. See the examples. The set A is representing a closed interval, the collection of all those numbers which are lying between 3 and 7, where 3 and 7 are also included. B is a set, or we can say is an interval of all those numbers which are lying between -7 and 6, where 6 is included but -7 is not included, and C is representing an open interval. Now, let us see pictorially how different intervals are represented. In this, you may see this is an open interval AB. These white dots, white circles are representing that A and B elements are not included in the interval. This interval is representing a closed interval, and black dots are representing that yes, A and B points are included in the interval. These two are semi-open and semi-closed interval. Now it is clear that in this interval, A point is included, but B point is not included. And in the last interval, which is semi-open and semi-closed, A point is not included, but B is included. So let us take one question and understand it more profoundly. In this, write the following as intervals. Set builder form is given for the sets and we have to convert it into an interval. This is the set of all those real numbers which are lying between -12 and -10. Students, what we have to observe? We have to observe the inequalities. You may see that the strict inequalities are there. So this implies that -12 and -10 are not included in the interval. So it is a open interval, and how we can write it as -12 and -10. What kind of brackets we have to use? The curved brackets. Now the second example, set of all those real numbers which are lying between 0 and 9. Again see the inequalities. Here it is less than equal to, and here it is strict inequality, that is strictly less than 9. So it is a semi-open and semi-closed interval where 0 is included in the interval, but 9 is not included. Now in the next question, write the following intervals in the set builder form. It is easy how we have to represent. Now let us see the solution. We can see this interval can be represented as this set, where it is consisting of all those real numbers which are lying between 6 and 13. Since 6 is not included, so there will be a strict inequality, and 13 is included in the interval, so there will be less than and equal to. So it consists of all those numbers x which are greater than 6 but less than and equal to 13. Okay? Similarly, let us write this interval -1 and 1, which is an open interval, in a set builder form, which is representing as set of all those real numbers which are lying between -9 and 1. Yes, both are not included in the interval, so there will be strict inequality. Okay students, hope you have understood how you have to represent sets in an interval form and interval in a set builder form. Now observe this example. We usually ask, if A is a set, then how many possible subsets it can have? Let us take an example in this where A is representing two elements, 1 and 0. How many subsets it can have? Let us list them. First of all, phi, that is the empty set. We have already studied that empty set is a subset of each and every set. So yes, it will be a subset of the set A as well. The set itself, we have also studied that every set is a subset of itself. So again, yes, A is also a subset of itself, so it will be the member of this set, PA. Now, each and every element will form a subset of the set A. So the other subsets are set singleton set 1 and singleton set 0. On forming a collection of all these sets, we find a new set, and this set is said to be power set. What is the definition? Let us see what it states. It states a collection of all subsets of a set A is called the power set of A. You may denote a power set by PA. You also observe that in PA, every element is a set. Yes, why? You may see that this element is also in a form of a set. This element, which is a singleton set, is also in a form of a set. Let us take one more example and understand power set more clearly. This example we have already studied. Let us add one element in it, which becomes a new set B. We have added one element, which is -1. Okay? Now, let us first list all the subsets. What are they? Empty set, the set itself. Two subsets will always be there. Now, all the singleton sets, that means all the elements, single elements. Singleton 1, singleton set which consisting of element 1, singleton set which is consisting of element 0, singleton set which is consisting of element -1. Now, all the sets which are having two elements, that are 1, 0, 1, -1 and 0, 1. Okay? So, this set is representing the power set of set B, which is having 3 elements 1, 0 and -1. Students, notice that if A, that is, has how many elements? 2. Then number of elements in its power set is how many? You may see, it is 1, 2, 3 and 4. Again, observe the number of elements in the set B and in its power set. Number of elements in the set B, how many number of elements are there? NB 3. Number of elements in its power set, count them. How many are they? 1, 2, 3, 4, 5, 6, 7 and 8. 8. Can I write it like this? And now observe the pattern. Can you observe a very important point in it? Yes, you may observe this. What it states? That if A is a set and M is the elements, then it can be shown that the number of elements in the power set is 2 raised to power m, where m is the number of elements in the set A. So, let us take this question. A is a set consisting of how many elements? 3 elements. Students, notice this set is representing a single element. Do not consider it as 1, 0, 2 and 3. It is consisting of 4 elements. No, it is consisting of 3 elements, 1, 0, an element in a set form which is 2 and 3. So, how many elements will be there in its power set? PA, number of elements in its power set, it is 2 raised to power the number of elements in the set A. How many numbers of elements are there? 3. So, raised to power 3, which gives us 8. Okay? Now, this is an exercise for you to find all the subsets of the set A. Now, let us take one more question on power set. How many elements does power set of power set of power set of B has, where B is a singleton set consisting of element 2. How many elements are there in B? 1. So, yes, it is. Number of elements present in B is 1. So, number of elements present in its power set, it will be 2. 2 raised to power 1. So, this gives us 2. So, number of elements in the power set of B will be 2 raised to power 2, as we can see and observe from the previous step. So, this gives us how many elements? 4. Lastly, what we wanted? The number of elements in power set of power set of power set of B, which gives us 16. How? 2 raised to power 4, which gives us 16. Hope you have understood how you can find answers to such questions. Students, there is an important point. Notice, these two notations, they are different. Phi and a set which is containing phi. These two are different notations. This is representing an empty set and this is representing a set which is having an empty set. So, the number of elements in an empty set are 0. So, we can say number of elements in an empty set is 0, but the number of elements in this set which is consisting an empty set is 1. Hope you have observed. Now, we study about universal set. This is the last type that we are going to study in sets. A set that contains all sets in a given context is called a universal set. For example, the set of integers, for the set of integers, the universal set can be rational numbers. It can also be real numbers. And from here itself, we can see that the universal set is need not to be unique. It can differ from context to context. Next example, for human population of studies, the universal set consists of people in the world. Last example, for the set of right triangles, the universal set can be the set of all triangles. Students, hope you have understood what is a universal set. So, let us quickly recapitulate what we have studied today. We have studied subset. A is a subset of B if every element of A is also an element of B. Some important points, that empty set is a subset of every set. Every set is a subset of itself. If A is a subset of B and B is a subset of A, which implies that both the sets are equal, that is A is equal to B. Proper set, if A and B are two sets where A is a subset of B but it is not equal to B, then we say A is a proper subset of B and B is a superset of A. Okay? Next, power set. Collection of all subsets of a set is known as power set. We have also seen the relation between the numbers of a power set and number of the set, which are the number of elements in a power set of a set A is 2 raised to power m, where this m is the number of elements present in the set A. Intervals of subsets of set of real numbers, and lastly we have studied about universal set. Students, hope you have enjoyed our session today. In the upcoming session, we will going to study about Venn diagram and operations on sets. Hope you have understood. Thank you.